Okay, now the point is how to draw that perpendicular bisector. Okay, so you will be getting questions. Let me give you a question here, an exam like question, or maybe the, the situation that we can manage. Now suppose we are given that there is this z minus 4 modulus that is equal to z minus 4 iota. Z minus 4 modulus is same as the modulus of z minus 4 iota. So first of all, you have to write it as z minus 4 plus 0 iota, and that is equal to z minus 0 plus 4 iota. Now there has to be a minus between these two. That means that z is going to be determined from this point. So suppose you have z plus 2 iota. Now there is no minus common here, but you will still be writing it as z minus 2 iota, because you have to bring in a minus in here. Okay? Okay, but now we have to show the locus of this z, which is equidistant from this 4 plus 0 iota and then 0 plus 4 iota. Okay. Now the examiner would like to see that, or you people are required to show that. Okay. Now this is your, this is 2, this is 4, and this is 2, this is 4. When we say perpendicular bisector, we are basically talking about two things. One thing is that the perpendicular bisector passes through the midpoint of the given line. Yes? And secondly, it passes in such a way that it makes a right angle. Okay? Now, so you should find the midpoint of these 2 points. So that will be 2, 2. So we know that the perpendicular bisector is going to pass through the point 2, 2. And if you are smart enough to imagine that, okay, let me suppose that there is a square like this. You have to use this, all your O-level knowledge here, okay? So here will be the perpendicular. Examiner has to see that your perpendicular bisector is passing through the origin and it is passing through the point 4.44. There is no need to use that compass and draw the arcs there and show them intersecting and then you draw that. We have to see that, yes, this student knows that if this is your original line, then the perpendicular bisector has to pass through the midpoint. So you should show this perpendicular bisector passing through the midpoint. And secondly, it should be reasonably representing a right angle between these two lines over here. ये नहीं हो कि आपको ऐसी लाइन बनाई हो आपने कि आपको नजर आ रहा है कि तो acute angle है इधर, there is an obtuse angle. Okay? So, so I have told you about the circle thing and the perpendicular bisector thing. The next thing is about the argument. Again, relating this with your O-level things. Now, bacho, suppose here is a line A, here is a line B, and I say that angle ABC is 60 degrees. Can you show the locus of the point C, provided it is above AB? Can you show the locus of this point C? Yes, you will simply mark an angle of, and you will show that it is going towards this side. So this is the locus of C, because you know that angle ABC is 60 degrees. Now similarly, if you are given that the argument of Z is, let's say, pi by 3, that is pi by 3. So we have to show the locus that where can this be. Okay, so you will have to have, they can, whenever it is asked about the locus, the first thing required is the Argand diagram. This locus can only be shown on the Argand diagram. Don't just start drawing the circles and the stuff, okay? The circles, the perpendicular bicycle, whatever you draw, it has to be on an Argand diagram, okay? So this is za. Okay, so now this is going to be, this is the, if this is 60 degrees or pi by 3, then this is the locus of z. Okay, now suppose you were given that the argument of z is between pi by 3 and pi by 2. So where would be this complex number z then? So up to this it is pi by 3, and this is the pi by 2 direction. So it means it is somewhere over here, है within this area. क्यों भाई? So that is how you can show the locus if you're given the argument. Okay. Now when we are given that the argument of z that is equal to theta, so this actually means that the argument is the vertex of that angle that we draw to show that argument is the origin. That is the origin. Now you can also be asked, okay, argument of z minus 2 plus 3 iota is pi by 4. So first of all, you will again maintain a minus like we were doing in case of that modulus thing. This is z minus 2 minus 3 iota, okay? And that is pi by 4. Now this would mean that now the vertex of that argument is going to be translated to 2 minus 3 iota, as it was in the case of the circle, the center of the circle, okay? So if you want to show this argument, you will have to, first of all, you draw this, and then you show this is going to be 1, 2, 1, 2, 3. So this has been, you draw these dotted lines over here. So this is the new, these are the new, like the whole real axis and the horizontal, I mean the imaginary axis have been translated with this 2 minus 3 iota. And here is that pi by 4. You show that pi by 4 over here. Okay, so this is the locus of z. Okay, let's move to the next video in next session.